Hi, and welcome to Engineer's Mindset. Today we'll look at the question which says determine the magnitude and direction of the resultant force acting on the I bolt as shown. So this is the bolt. Alright, so we'll start by analyzing the free body diagram. And from free body diagram we simply have our Cartesian coordinate, which is simply our graph, two-dimensional graph. So this happens to be the positive x component and this is positive y component. So let's represent what we have on the I bolt in the diagram and see. Okay, so if you notice, if I draw an imaginary line from this point, and this happens to be my y component, and this happens to be my x component. So which means this is now a Cartesian coordinate system. So on this quadrant, we have a force from the origin pointing upwards. That force is 80 newtons, inclined to the x at 30 degrees. So it means we'll have from here to this point, we'll have a force 80 newtons, inclined at 30 to the horizontal. So we'll have this. Also from that same quadrant, we have a force of 120 newtons inclined at an angle of 40 degrees to the next force. So which means from this origin we also have a force of 120 newtons outwards. So we have 120 newtons force inclined at 40 degrees to the next force, which is 40 here. So it means that this force will take a total of 40 plus 30 to get to the x component. So it takes a total of 70 degrees to get to the x component. Also on the graph we have, on the I bolt, we have another force from the next quadrant moving outward from the origin, 150 newtons inclined at 35 to horizontal. Okay, so we also represent that. So we'll have this force outwards, 150 newtons inclined at 35 to the horizontal, 35 degrees. So this happens to be a negative component of x. Okay, and this happens to be a negative component y. So we'll take summation of horizontal forces at once. So summation of x component force So we'll take this all at once, summation f of s. Okay, now from the analysis and from the shortcut, hold the tip of the arrow, pull it till it meets the s line, and by so doing consider the angle it passes through and then consider the direction of the arrow. So if we do that, hold the tip and pull, notice that this first tip points to the right. If you pull this is the direction of the arrow, pull this till it meets this line, also it points to the right, so it's positive. And it went all the way from this point to this point. That means it's covered 30 degrees, which is this angle. So it means it's going to be 80 cos 30. So we have 80 cos 30. Okay, also hold the tip of the arrow of this other force, which is a 120 newtons, resolve it till it meets the s line. See, notice the direction of the arrow. If I pull this arrow till it meets this line, it also points towards the right, so it's a positive force. And again, it went all the way from here, 40 plus 30 to get to this point. So it means it covered a total of 70 degrees. So it's going to be plus 120 times the cosine of the angle it passes through. So 120 cos 70. Similarly, hold the tip of the arrow of this force, pull it till it meets the s line. Watch the direction of the arrow. If I pull this force to this point, it points to the left, so which means this force is a negative force. So it points to the left, so which means it's negative. Similarly, it went all the way from this point to this point, so which means it covers this angle 35 degrees, so it's going to be cos of the angle it covers. So you have minus because it points to the left, 150 cos 35. Okay, so we'll start our analysis. Summation f of s is now equal to 80 cos 60. 80 cos 30 is 69.28 plus, so we'll find 120 cos 7, that gives us 41.04 minus, we evaluate 150 cos 35, that gives us minus 122.87. okay, so summation f of x is equal to, let's evaluate all that together. Okay, so that gives us minus 12.55 newtons. So that's summation of force in the x component. Okay, so we'll take summation in the y, summation of y component force, summation f of y. So we resolve all the force in the vertical direction. So now it is interesting for you to know that if here is 30 and there is 40, which makes it 70, it means here is simply 20, because angle on the quadrant is 90. So this whole angle gives us 90 degrees. Okay, so if we choose to resolve the first force, this 120 newton force, to the y, hold the tip of the arrow of the force, pull it till it meets the y line. If you do that, consider the angle it passes through. So while you pull this force to the y line, check the direction. The direction is pointing outwards. If you pull to the y line, it still points outwards, so it's positive. It points vertically upwards, it's positive. And it moved all the way from this point to this point, which means it covered this angle from here to here, which is 20 degrees. So it's going to be this force times cosine of the angle it passes through. Alright, so we have 120 cos 20. Also, if I want to resolve this force, hold the tip of the arrow of the force and pull it till it meets the vertical line. So if I pull this force till it meets this vertical line, it also points upward. If you check the direction, it's pointing out. So if you pull it, it still points upward, so it's positive. Check the angle it covered. It moved all the way from here to this point, so which means it covered 40 plus 20. So total angle it covered to get to this point is what? 60 degrees. So we'll have plus. Okay, so it's going to be this force times cosine of the angle it passes through. So we'll have plus 80 cos 60, because it passes through 20 plus 40 plus 20, sorry, that's total of 60 degrees. And then finally we resolve this force with the vertical, hold the tip of the arrow, pull it till it meets the vertical line. It still points upwards, it's positive. If here is 35, it means this angle is simply 55. So it passes through from here to here, so that means it covered 55 degrees to get to the what? Vertical component. So it means, and it's positive, so it means it's going to be plus 150 cos 55. So we evaluate this and see summation f of y is now equal to, so we evaluate 120 cos 20 of 112.16 plus 80 cos 60 is 40 plus 150 cos 50. So we'll have 86.05. So we'll evaluate all and see what we'll have. So we'll have 230.81. So okay, getting this, recall that resultant force is simply square root summation f of x plus summation f of y all squared. So resultant force is simply square root summation f of x give us minus 12.55. So we'll have minus 12.55 all squared plus this gave us summation f of y was 230.18. so 230.18 squared. Okay, resultant force is now equal to, let's get that and see. Okay, so 12.55 squared give us 157.7, okay, 0.50 plus, okay, so square of minus 12.55 give us this, and square of 230.18 give us this. So we add them together and we obtain the square of this, obtain the square root of this value. Take the square root, we have the resultant force to be 230.52 newtons. So this is the resultant force. The next is to find the direction, and direction is theta, and we obtain that to be arctan summation f of y summation f of x. Okay, so theta is equal to arctan summation f of y is 230.18, summation f of x is minus 12.55. okay, theta equal to arctan. Let's evaluate this, and that gives us minus 18.3. so find the arctan of that value, see what we'll have. So the arctan gave us minus 86.7 degrees, 0.9 degrees. So we'll have that to be minus 86.9 degrees. Okay, so but we have to eliminate this negative sign, and to do that we simply add the angle to 180 degrees. So it now implies that theta is equal to minus 86.9 plus 180 degrees, so which means theta is equal to 93.1 degrees. So that becomes the direction. So always take note, whenever you have a negative sign in the direction, always add to 180 degrees to eliminate to eliminate the negative sign. That is if the angle is between 0 to 180 degrees, but if it is above 0 to 180 degrees, you consider to add either 270 or 360 degrees depending on the number. All right, thank you very much. I'll see you in the next video. Please don't forget to like or share the video if you find it interesting, and then comment. Thank you very much. Comment if you have a question, and then subscribe to my channel. Thank you very much.